little example problem here, and I would encourage you again, you know, too often you get stuck with getting the right answer without thinking about the algorithm or the method used to find that right answer. If you, oh, it has not stopped working. All right, well, that'll be the end of that. Then let's go back. I remember the days way before we had computers. Life was so much easier.
Really?
Oh, we didn't have to worry about this. Never did my chalkboard shut down, I can tell you that.
You didn't have software.
What?
You didn't have software.
What does that mean?
Chalkboard. He said chalk. Oh.
I got the toolbar there. Why don't I have?
You said software.
Give it a second here. I could actually go to, there it is. What are we talking about? Word problems. Oh, this is still not gonna be good. Like I said, we get too wrapped up in right and wrong answers and just knowing what to do, rather than thinking about how to get that here. So here, write down this problem. In the first half of the game, Alfredo scored 12 points, or puntas. In the whole game, he scored 27 points. In the whole game, he scored 27 puntas. How many points did Alfredo score in the second half? How many points did Al score in the second half? Okay. To which I know you understand that this, you'll look at this and go, well, he scored 15 points or whatever it is there. But I don't care so much about that. I care about you kind of organizing your thoughts and thinking about what's really happening here. And if you were to write this out in an equation form, how would that look? Well, if you're doing that, this is what you know. First, he scored 12 points, right? Then, if you add how many points he scored in the second half, you are going to get a total of 27 points. This right here, if you can do this for an easy problem, you will be able to do it for the hard problems that don't come to your mind automatically. Now, how do I get 15 with that equation? Dost thou remember? Jacob?
You subtract.
Right, in equations, you always think about doing the opposite. This is an addition equation, so to get the letter t by itself, I actually subtract 12, because 12 minus 12 is nothing. But a rule of equations is if you do it to one side, you have to also do it to the other side. Keep it on balance, and p then equals 15. So it's more about the process than really about, you know, you just being able to spout off whatever answer is there. Let me see if I can find it. Here's another one. JFK was elected in 1960. Anybody know who JFK is?
Yeah. Not a Kennedy.
Elected in 60. 1960. At the age of 43. At the age of 43. What year was he born? Now, if I asked you to write an equation with that, how would you write that? What equation could you give me for that? I know you probably know what the answer is, but you know, how would you? And by the way, this is the book calls this a later than earlier problem. You've got later, you've got earlier. Abram says
1960 minus 43 equals his age.
1960 minus 43 would give you 1,917.
He's pretty old.
Is that right? That would give you the year he was born, but not necessarily his age.
Wait, so we're trying to figure out his age? Right.
Yeah, it says what year was he born? No, it says what year was he born?
Oh.
Now, let me tell you what the book would do, because you actually have, I mean, you get the right answer if you do it that way, but think about it like this. If you take the later date, which was 1960, and you take away the year he was born, that would be a little like this. You know, if I was asking Wade, if Wade didn't know how old he was right off the bat, how would he figure out how old he was? Well, he would take what this year is. What year are we at? We're at year 2017. He would then subtract the year he was born, which is, Wade, 2004. And depending on if his birthday's already happened or not, Wade should be 13 years old. Well, that's the same thing with JFK. Okay, you take the year it was when he was elected, take away the year he was born, and he needs to be 43 years old. Now, how would you do that problem to solve it? Ooh, wait, I caught him on just a little bit there. A couple different ways you could think about it, but this is what I would do in this case. Evelyn?
1960 minus 43.
Yeah, but why?
Because that would give you the year he was born. Subtract 43.
But why? How do you know to subtract 43? You are saying because you know what the answer is. You're not saying because you could do that in any other problem. You know, if I gave you this, 7,536 minus m equals 982. How would you know what to do there? You're just saying because you.
You would subtract.
I know,
I
well-
don't know. Okay.
What about this? X minus 8,243 equals 769. But how do you know that?
Because that's
Because you
how it
just
goes.
know.
I spent forever telling you what to do on these.
Because there's
You
nothing
don't-
else to do
you
except
don't
add.
always, you don't always just know, Tyler. You
Think of an easier problem.
exactly. Make it an easy problem like a subtraction problem like 8 minus 2 is 6. If you're missing the middle number, what do you do with 8 and 6 to get 2? You subtract them. If you're missing the first number, what do you do with 6 and 2 to get 8? You add them together. So here, yes, you are going to subtract them. You guys said subtract simply because you knew what the answer should be, not because you knew that was what you always would do. If you think of an easy problem, you will never, ever, ever, rarely, unfrequently, disproportionately go wrong. I'm stopping.